choosing and building better images. That's my talk. Hopefully you're here for that. Quick introduction. My name is Chet Burgess. I'm presently a principal engineer at Cisco. And for the past 2 years, I've been working with a couple of our container and Kubernetes-based products around security and compliance of containers. Prior to that, I've had a number of different roles. I've been a director of engineering. I helped start an OpenStack cloud-based startup where I was VP engineering and chief architect. I've worked in high-volume transactional websites, where we're processing hundreds of millions of dollars of credit card orders, and I've also worked in higher education. As a result of all that, at different times in my career, I've come into contact with quite a few different compliance standards. Nice little laundry list of acronyms: HIPAA, FERPA, GDPR, SOC, both of them, SOX and SOC. Why they decided to create two of them, one letter difference, I don't know. PCI, FedRAMP, things of that nature. So the first little part of this talk, I'm going to talk a little bit about compliance and kind of set a generalized framework for what compliance is and how that relates to what I'm going to talk about in containers. I'm not going to talk specifically about one of those alphabet soup of things I just mentioned. I am going to pull out a few general things and boil them down and distill things that are, hey, kind of all of these standards basically sort of say this thing. And we're going to talk about this generalized thing. And then I'm going to move into talking about kind of some common problems we see around that and some simple common fixes for that. By far, it's not going to be an exhaustive list of every problem, nor an exhaustive list of every way you could solve those problems. We just don't have enough time. Right, so I have to put this up here. Disclaimer, I'm not a lawyer. I will be talking about compliance. There are legal aspects to compliance. I am not a lawyer. I work with lawyers, but I am not one, so please do not consider anything I am giving you legal advice. Additionally, as I'm required to say, I am giving you my opinion and experience based on my 20-some-odd years in the industry. And I am here officially as a Cisco employee, but I am not representing any official stance nor an official endorsement from Cisco. Okay, so like I said, we're going to talk at first about compliance. So I'm going to put a statement up here and talk about it a little bit. Compliance is about risk. What do I mean by that? Most compliance standards that we encounter out there, they're designed at their core about being able to quantify and qualify the risk inherent in something. Now, as it relates to us, typically that is some computer system or set of systems or services or software that we are either administering, running, or shipping. Notice I didn't say anything about ensuring that any of those things are secure. That's intentional. Security, as again it relates to those things, computer security, that is the primary tool we have for helping to mitigate that risk. But it is oftentimes not necessarily the goal of the compliance standard. It wants to make sure you understand your risk, you can quantify your risk, and you can mitigate it or accept it. Now that's very important. Now oftentimes security and compliance go hand in hand, and oftentimes they do align, and what is in a compliance standard gives you better security, or if you make security better, you will inherently reduce your risk profile as it relates to the compliance standard. But sometimes they are orthogonal to each other, and every so often, unfortunately, they're in direct opposition to each other. So it's important as we talk about these things, not necessarily to think solely from the perspective of, is this more secure? Is the solution I'm telling you more secure than the problem I'm describing? Sometimes they might be of about an equal level of security. But what you need to think about is, does it change the risk? Is one behavior or activity riskier than another? Maybe, maybe not. So I'm going to talk about 3 generalized obligations we have under compliance as that overarching concept, right? Again, I'm not going to pick out any one single compliance standard, but there's kind of 3 obligations that we exist that come into play. First off, there's an open source software compliance obligation that we all have. Even if you're not operating in a regulated industry, and you don't have a certain compliance standard like HIPAA or GDPR that you're trying to meet, if you're using open source software, there is still a compliance obligation you have there. And we need to understand that and all be good citizens towards that. Additionally, most compliance standards have a requirement that comes down to something like ship only the software you need. This is analogous to don't run services you don't need, right? You know, have a minimum footprint. And then finally, they all have, again, something that comes down to keep your software up to date. You know, apply patches, things of that nature. I'm going to take a moment to talk a little bit about open source software compliance. This is not a talk about open source software compliance, but I'm going to talk a little bit about it because it's probably the thing that I see the most number of companies and developers get wrong. And so open source software, I'm actually going to read this first sentence. Open source software exists within a legal framework that creates obligations for the developers and distributors. I could add also there the people who administer and run the stuff. What do I mean by this? Well, frequently I hear developers say, well, it's open source software, so it's free. We can do what we want with it. No, wrong. That is not what that means. Almost all open source software is licensed under a license. That license is a legal document. It is free in that the developer has said, you do not necessarily have to pay me for it, but it is not free of legal obligation. That license requires you, the developer, the distributor, the administrator, potentially to do certain things and adhere to certain rules. So you need to understand the licenses that are in play for the software you're using or developing or linking against, and what the obligations there are. Sometimes it's as simple as just, hey, don't modify the source code. In other cases, it's just say you're using us. There's also other licenses that are more restrictive. There's a trend these days. Elasticsearch is a good example. If you don't know what I'm talking about, just Google for Amazon versus Elasticsearch license. You'll get a lot of hits. You get some great stuff. There's a trend now where companies are creating their own open license that is sort of analogous to some of the licenses we know about, but then they have certain restrictions on the use of their software to combat certain types of activities that either they have moral objections against or to try and combat a certain competitive climate or anti-competitive climate. So it's very important to understand those licenses and what the obligations therein are. The Linux Foundation has a great site about open source software compliance. They also have some tools listed there that can help you. I'll throw up a few links later on about some tools there too. But it's super important that you understand and get this right. If you work for a large company, chances are quite good you actually have a company-wide policy or standard about open source software compliance, and there might even be an office within your company, if you're large enough, that handles this. If you're a software developer and you use a lot of open source software for your employer and you ship open source software under a commercial license through your employer and you don't have any idea about this sort of thing, talk to your boss, because chances are good you need to be aware of it. Okay. So now, let's kind of get into containers. So what's wrong with containers as it relates to these three things I've just talked about: open source software compliance, ship only the software you need, and or enable only services you need, and keep your software up to date. So what's wrong with that with containers? Well, oftentimes what we discover is we don't know what's in a container. I don't know. Docker pull Python :latest. What is it? Python. Okay, but what's actually in it? Well, surprisingly enough, that container contains something like 60 to 70 individual components, each with their own license. Reference back to what I said about open source software compliance and knowing what you ship. You didn't just ship Python, you shipped 60 some odd other things in addition to Python. Frequently we'll discover that there's unnecessary software in there. I'll talk about this later on. I'll give an example of a particular container from a fairly well-known cloud-native project that I have run across that I've had to use that's over 3 gigs in size. It's a single 50 meg statically linked Go binary. Why is the container 3 gigs in size? There's a lot of unnecessary software in there. And then out-of-date software. You know, I mean, the second you publish software, whether you're doing a build and pushing a package to PyPy, or whether you hit that release button in GitHub and it bundles a little tar.gz there and publishes you for it, or you push something to Docker Hub. You got to continue to build it. Second you publish it, guess what? It's out of date. Because you probably have a dependency in there somewhere that within the next couple weeks is going to have a new update. Chances are good, probably because there's a vulnerability in it. So you need to be always thinking about that. Okay, common problems and fixes for this. So I'm going to run through a series of we have kind of three categories that my colleagues and I like to think about that are the most common. And I'm going to talk through some examples of those, and then I'm going to switch out and show you some strategies to address that. I'm going to be switching between PowerPoint here, web browser, and the shell. And I apologize. Sometimes the screen takes a minute to pick that up. It might go black for a minute. So if I pause, it's just because I'm waiting on the screen here, right? OK, so the first problem, the biggest problem, is what we call dependency rot. This is by far the single most common problem we see with containers. And this is caused by a number of things, but the top ones are, a very common one is someone says, well, I picked my from line, and I know it works, I'm just going to use that. And so I encounter things like this, from Debian stretch 20190506-slim. Yeah, that's a date stamp. That container is 6, 7, 8, 9, almost 10 months out of date. Guess what? There's more than a few CVEs in that base container. Some projects just have slow release cycles, or they don't push out updates that often, and so for good reason. Maybe they just, it takes them a while to develop new features. They don't feel like there's enough bugs in the actual project itself to warrant a bug release, or there's just not enough new features to warrant a new feature release, so they don't publish an update. But again, they've published a container that's now 6 months old, and it's got Ubuntu base. And in 6 months, there's more than a few CVEs probably in those 60 some odd packages they have in their base. And another common problem is just projects or development processes that lack a good way of managing and monitoring their dependencies, right? Oh, I don't know, I picked this particular version of Python requests, and it works for me, and I've never needed a new fix for it. So my requirements.txt file just says Python's request equals 1, 2, 3. What's wrong with that? Well, you picked that 5 years ago when the project started. There's more than a few issues with that version of Python requests. So how do we solve that? There's a number of different ways we can solve that. So a simple solution, which I say with a little bit of trepidation, is use a sliding tag. So most commonly, we think of this as being the quote-unquote latest tag in the container world. Now, I say be careful here because there's a lot of misconceptions around latest. Let me be very clear. Latest is a string, just like any other Docker tag. That's all it is. There's nothing special about it. There's no magic on Docker Hub that ensures latest always points to the most recent container you push to your repo. There's people who actually believe that one. There is no enforcement in Docker or Docker Hub or any other container runtime that latest has to be up to date in any way. It's just a tag that the community as a whole has agreed should represent the most recent thing you published. But it doesn't always. So be careful. Look at the way the project is doing things. Look at how they're publishing stuff. See what their policy is. A lot of projects, especially base operating system images as they're published to Docker Hub, things like Debian, Ubuntu, Alpine, CentOS, and also language runtimes, Python, Golang, things like that. They have both the notion of a latest, and then they also kind of have version-specific sliding tags, right? So you can get like a Python 3.8, which will slide with you, but never move to 3.9. Or you can get, a Debian 10, which will always slide through Debian 10, but never upgrade you to 11 in 25 years, whenever Debian's going to do their next big release. Word of note, we did recently have Debian do a big release. We went from stretch to buster, and that's great, except for all of a sudden, latest or stable as a sliding tag doesn't mean what you used to think it means. All of a sudden, you just got a major version upgrade, and hilarity can ensue. And then I've thrown up a link here. It's an interesting kind of discussion about some of the potential issues and things you need to look at around using this notion of latest. Another thing you can do very simply, let's say you do have a fixed Debian from line. Throw an apt-get dist upgrade into your container. There's nothing wrong with that. You'll pull in some updates. You'll fix some CVEs. Yeah, you'll create a layer. Yeah, that means you'll ship a little bit extra data, but rather you ship a couple of updates to me rather than give me a container that's a year out of date and has 25 CVEs that I now have to go, oh, I can't use that. Guess what? I'm going to build the container myself now. Update your from line. This is a simple one. You picked a great image. Guess what? Every couple months, probably time to move, if not sooner. Other solutions here. Do regular rebuilds. Even if your software doesn't change, right? You can add like a build rev to the end of your project, right? Your December version might be 1.2.3. Add a -1, -2, -3. Yeah, your software didn't change, but it's a new build rev, and you're publishing it because guess what? It's been 3 months. There's some CVEs. Let me publish that out there. Let me get you an update. Docker Hub does have a feature if you use Docker Hub called repository links that can help. You can build a dependency between containers that way. There are some limitations to it. It does not work for what Docker Hub considers official images, and there's a link to what those are. It's kind of hard to know what is an official image short of just pulling up that link, but unfortunately a lot of the base OS images are considered official images. It also requires your from line in your Docker file to be a fixed string, not a variable. You can't pass a build arg in for your from if you want this to work. And the image in the from line also has to be hosted on Docker Hub. But there can be some help there, potentially if your project is a type where you might have multiple images that depend on each other, or you depend on something that's not considered a official image. You can get some value there. The other thing for Dependency Rot is monitor your dependencies. There's a whole ecosystem these days. There's a lot of companies as well as open source projects out there playing in this space where they can provide tooling to help you manage and monitor your dependencies. GitHub has a great feature. They have some built-in dependency monitoring, which is pretty much just enabled by default. You can even do some configuration on it, and you can even make it auto-propose PRs for you if it detects that you have a dependency that's out of date. Unfortunately, the built-in GitHub dependency monitoring does not work with Docker files. It works for a lot of language-specific stuff, Python requirements. If I talk about Python a lot, it's because that's my first language of choice. I apologize for anyone who doesn't like it in the room, but so like I said, the built-in dependency monitoring stuff in GitHub does not work with Docker files, unfortunately. But there is a GitHub app called Renovate, available through the app marketplace. Costs $0, so it is free. That will monitor Docker files within your repository. Basically, looks for anything named Docker file full string or Docker file dot anything anywhere in your repo, and says, "Cool, I'm going to monitor that." The Renovate GitHub app, it started as open source. The npm.js link at the bottom there is the open source repo. And the GitHub app itself is provided by a company called WhiteSource. And they're the same company that provides all the backend functionality for GitHub's built-in dependency monitoring that's there for free. So it's kind of an extension of that. It's really cool. It'll auto-propose PRs to your repo. Won't merge them, but if you want to, you can configure it so it can merge them. That basically says, hey, guess what? You had this in your from line. There's a newer version. You should look at that. You should update. And like I said, there's a number of tools in this space. This is an emerging space. There's a lot of companies and open source projects trying to provide solutions here. So we're going to hit the first of the demos. This isn't so much a demo as much as this is me just showing you a couple things on Docker Hub and GitHub. So hopefully the web browser comes up. Like I said, hey, come on. There we go. Great. Okay. So here I am just in Docker Hub. I have a public Git repo, which I'll show you in a second, as well as a public Docker Hub repo called Docker Examples. There'll be a link at the end of the presentation to where all this is. Everything I'm showing today is all configured and available there. You can use it however you want. So here in the Docker Hub config example, you can look at if you go to configure automated builds, you'll see where it's possible to turn on these what's called these repo links, which I was talking about. So, enable for base images, and then of course here it gives you the same warnings I gave you about the from line. But if you've got some build rules defined with auto build enabled here, then it will monitor anything that you've got a build ruled for, and if it detects that there's a newer version of the base, it will automatically rebuild for you. So we can see what this looks like by, back. If we go look at the build history for this repo, well, first what I'm going to do is I'm going to actually trigger, so I have, here's the actual repo on GitHub. I have 2 Docker files for demonstrating this. First, I have what I call dockerfile.base. And this is really simple. It's just, I'm basing this on Debian Buster Slim. That's a sliding tag from Debian that'll always be the Slim version of Buster. And all I really do here is just, do an apt-get, update, clean remove, blah, blah, blah. Don't really change anything, just so that there's a layer there. Throw some labels on it and run bash. It's a really simple container. And then I have dockerfile.curl, which is based on that same container that is called base latest that we publish out of Docker Hub. Now this one happens to install curl and runs curl. And all the entry point really does is make sure we parse the args for curl correctly. So you could do like docker run curl, splat. Really simple example. So on the Docker Hub side, right now I'm going to trigger a build of base latest. Hopefully by the end of the talk, we'll come back here and we'll see that curl latest is also rebuilt. But the Docker Hub build infrastructure can sometimes take quite a while to do a build. Sometimes 20 minutes, sometimes an hour. We'll see if it comes back in time. But what you can see in the history of the repo here is a day ago when I was setting this repo up, commit AD766A7, that's my hash from GitHub, came in. And what it did is it first rebuilt the 3 containers that are part of the build rules. And so that's curl latest, that's not really highlighting well, but right here, curl latest, base latest, and multi-latest. It builds them in, unfortunately the ordering is quite literally in alphabetical order. But curl latest depends on base latest. So you'll notice after these 3 builds were successful, there's another build on the same hash where it's building dockerfile.curl again. And it says the reason here doesn't say multi-latest, which is the name of my automatic build rule. Instead it says, hey, CF version docker, blah, blah, blah. What that means there is it's saying, I'm reading this image because its dependency changed, right? And so like I said, hopefully we'll come back. Maybe this will be done by the end of the talk. We'll see. So the other thing I wanted to show you guys was renovate. So I have set up renovate on this repo. It's really simple. I have some links in my presentation that will be available online. You go through to the app, to the GitHub Marketplace. You select the app. It says, "Hey, do you agree to the billing?" The billing is literally $0. You say yes. You authorize the app to have access to the repos you want, and you can configure it. It has some pretty rich configuration. I'm just using the simple basic configuration. And what I did here is I have another Docker file called dockerfile.reno-example that I created. And again, this is a very simple one. In this case, what I did is I used, this is one of the Python language runtime containers. And I intentionally picked a older one, Python 3.7.1. It's kind of an old version of Python. I mean, it's not super new. And all I do is I just pip install virtualenv, something simple so the container has something to do. Well, what happens is renovate will run about once an hour. And if it detects Docker files that are out of date, it proposes a PR. That's at least the default configuration, which is all I've done here. So you can see here, this PR, which came in yesterday when I set this up, because again, I didn't want to have to try and time things and hope that our run happened during our talk. Here's the PR, right? And so it's got this nice little description of what it's doing, and it's saying, hey, Python, I want to change it from 3.7.1 to 3.8.2. Some nice little checkbox if you need to rebase this because it's out of date or something of that nature. And if you go in here to the files changed, you'll see in my dockerfile.reno example, it's just changing that from line to 3.8.2, which happens to be the latest release of Python, right? So this is super, super simple, easy to set up, can monitor your Docker files and tell you if your bases are out of date. Again, it needs the base to be a string, not a build arg. But it's a simple way to do this, and Renovate can do more. You can configure it to auto-merge PRs, different rules for how to do versioning versus version detection. You know, maybe you've got one Docker image based on another one, and you don't exactly use like straight semver. There's ways you can write rules and regexes to help it. So it's a pretty neat tool that helps out quite a bit. So we'll go back to presentation. Cool, great. Oh, and I forgot to say at the beginning, hopefully there'll be some time for questions at the end. I think so. But we also have an hour before the next session, so if there's more questions, I can always hang out. But. All right, the next common thing we call is the kitchen sink problem, or the kitchen sink image. So this is what I was talking about earlier, very large container images, 3 gig container images whose entire purpose is to run a 50 megabyte statically linked Go binary. What did you put in there? You have at least one kitchen sink, maybe 2. Frequently, this will be, what you'll also see in the image is it'll have a lot of layers. I don't mean like 2, 3, 4, 5. I mean like 15, 16, 17, 18, 20, 25. You know, that's usually a sign of something is, there's a lot in this container, a lot more than you think, right? We'll see things like the entire get tree will be left in an image. All the build tools and assets for building all the way will be left in the image. People will the really interesting thing is where people don't quite understanding how layer works in Docker, and right at the end they'll have a run command that just RMs a bunch of stuff that was in their previous 15 run commands. That doesn't work. You unlinked it from the final file system, but that's still in the image. It's all still in there. What's worse is when people do this for things like their get tokens. They write into the file system, they do a bunch of stuff, they remove them, they go, hey, I'm safe, right? No, I can take your image, I can unpack it, and just use tar, and I can get your GitHub token. That's always a fun one. So how do we solve the kitchen sink? Oh, hang on, I think this mic is rubbing. There we go. Well, the first thing to do is as you're writing your Docker file, as you're reading your Docker file, think very carefully about what data is going to be left behind. So you want to be removing your build dependencies. You want to be cleaning up after your package managers. And the way to typically do this is to think through every run command should be thought of as a purely atomic operation. Once that run block is done, you can't change the content it created. It is there. It is permanent. You can unlink it from the final version of the file system in a later run command, but you can't actually remove the data from the layer that got created from that run command. So think very carefully about what you're leaving behind. Typically, that means you're going to want to limit the number of run commands. You're going to want to have fewer, longer run blocks where you're stitching together multiple commands. Be very careful about automatic installs. A lot of package managers these days, apt is an example here, wants to also give you the recommended packages. Not just the required dependencies, but the recommended ones. So look at your package manager, see if it's doing something like that, see if there's a way to configure that. For apt, you just pass no install recommends. Again, if you see a bunch of Debian-based examples, sorry, Debian guy. But there's equivalents in other package managers. Be very, very selective in the use of the copy command in your Docker files. So something I see really often, copy space dot space slash. Cool, I have your entire Git history now. Did you mean to give that to me? I'm not sure I want it. Copy commands, that's another example of anything you copy in there is there forever. Even if you RM in a later run block, I can get it back. Still in the image that you shipped. So be very selective about your copy command. If you only need a certain number of files, copy those in. Use build args for sensitive data. Build args do not persist. The value of a build arg does not persist in the built container. If you need to pass a token for talking to GitHub or another API service into your build process, do it via build args, please. I don't want your GitHub tokens. Other solutions. So there's a couple of great solutions that kind of encompass everything I just talked about here. So multi-stage Docker builds. So 2 years ago, this was a bit of a new concept. This isn't really all that new anymore. This is a fairly well thought out thing now. It's no longer an experimental feature in Docker. It's part of mainline. Docker Hub even supports this for builds now. So you can take a single Docker file, and you can build a sequence of images, and you're allowed to copy data between them. So let's say I need my entire Git history, and Bazel, and Go, and a million other dependencies to build this, say, I don't know, 50 meg statically linked Go binary. Great. Do that in one layer. Make that layer 3 gigs. I don't care. Then do another layer that just copies that single static build asset into it, and then publish that final layer. You'll have a really slim, really nice container, and you still get to use Docker to do all the abstraction of the build stuff. It's actually a really great way to do that. And then a newer experimental feature is, as of Docker 1.13, there's an experimental flag. It's still considered experimental. It's the squash flag. It's supported on Docker build. So what squash does is it will take everything that's in your Docker file, and it will squash that into a single layer. Now, it will not squash the layers in your base. So if you say from something with a couple layers, and then you run 10 run commands, well, it'll squash your 10 run commands in one layer, but you'll still have the layers from your base. Like I said, it's still experimental. As a result, it's not supported by the Docker Hub build infrastructure. So if you're relying on that, unfortunately, you can't use squash. But word of warning, do use squash sparingly. I mean, one of the advantages of Docker, especially if you're running a large-scale service and you're deploying hundreds of microservices, is if you build and layer your Docker images correctly, you can get a lot of benefits from image caching and layer caching. When you squash, obviously, effectively every layer becomes a unique layer because it's what was generated in that specific build. So just be careful about that. So I'm going to do another demo here where I'm going to show both a multi-stage build as well as a squash build real quick, once the screen catches up. Okay, in this one we're going to be in the terminal. So I've got a check out of that Docker examples repo that I was showing on GitHub previously. Everything is still in there, so again, you can see how this stuff works. So what I want to do is I want to show an example of first a multi-stage build. So I have dockerfile.multi here. So it's pretty simple. Whoops. I'm just going to scroll just a little bit off the screen. So in this case, I'm building a very simple hello world Go binary. So I begin by saying, all right, I'm going to need a Go runtime to do the build. So my very first line up here, I'm saying, oh, just pull the latest version of Golang based on Buster. And and it says as builder. So that's a way of assigning a name to that image so that I can reference it later, right? So now I go through and I copy my simple hello world Go file from the Git repository in there. I do the build. Great. So now I have a new from scratch. So again, what I'm doing here is I'm trying to produce a simple hello world Go binary. So I'm going to statically link it. So I don't need anything. So I'm going to start from scratch. And then I'm going to copy that built binary. Now, you'll notice here on the copy command, I say -- from equals builder. This is part of the semantics of multi-stage build. I can tell it what I want you to copy, not from my local file system, but copy something relative to this previous image you built in here. And you can have multiple stages in here. I'm using a simple example with 2 stages, but I've seen examples where they have 3, 4, 5 different stages that they do things in. So I just copy the binary from go hello world to /hello world, and then the rest of this is I just set my labels and run my command. So we can build this now, and I have it in my history, so I don't have to sit here and type and make typos, right? So we're going to do the Go build. Again, it's a pretty simple container, so it'll be done pretty fast. And what we'll look at here, first we're going to do an image list, right? And we'll see that, first off, there's the Golang container that I used as my builder. It's 809 megabytes. I mean, Go's not small. Most language runtimes to do compilation aren't small. As I say, 809 megabytes, but the image I just built, multi-latest, is 2 megabytes. That's because it only contains my hello world program, nothing else. So I get the full benefits of using Docker to have a full build environment. You can customize this obviously however you want. I just picked an example that allowed me to use a very simple one. And my end result is still a very, very small, very slim container that if we run it, oops, See, this is why I have these things in. Will just tell us. Ah! It'll tell me you should have just copied the image ID. Hello world, because it's just a simple Go program that just prints hello world. So multi-stage builds can be very, very powerful. If you haven't experienced those yet and aren't using them, and you have fairly complicated builds and you're having to do a lot of you need a lot of different dependencies. This can be a pretty powerful way to solve that. The other thing I wanted to show was the squash example. So in this case, I have another Docker file that's a really simple one. It's just the curl example again. I've put it in a special file just so I can show this. And this one's just based directly on Debian Buster. I didn't do the linked thing that I set up to try and show the repository linking in action. But so what we can do here is we're going to build two versions of this thing. First, we're going to build a version that is not squashed. Right here, right? Just a standard Docker build, as you would expect. No extra arguments. So let's go into the build here. So glad Scale has fast Wi-Fi, otherwise that wouldn't work. And now if we look at the image, oh wait, I want to inspect it. So if I inspect that image, first I'm going to look at the Debian Buster Slim image that this is based on, and we'll see that there's a single layer. Most of those base operating system images come pre-squashed for you. They build them as a single layer. I don't know that anyone can remember a full SHA-256 hash, so we'll just look at the last couple of digits here, 42DA. We'll try and remember that, 42DA. Now, if we inspect what we just built, which is the squash, no squash image, whoops, 136 is what I wanted to do. We'll see there's three layers here. And the first one is 42DA, that's our base. And then there's two more layers there. Now, why two layers? There's two layers because we have two things that generate a layer. We have a run command, where I install curl, and then we have a copy command, where I create the entry point. So those are our two layers. Now, if I run this with squash, what you'll see is, do the build, great, because everything's cached. Isn't caching wonderful? If we inspect this now, there's only two layers. Again, we have 42DA. We have another unique SHA. Now, if we looked and compared it to the other image I built, no squash, you'll see that's a different SHA there. So this is an example, like I said, what Docker's done is it's taken all those layers and it's smushed them together. So again, if you need to have multiple runs or multiple copies and there's some data that you don't want in your final image, and for whatever reason multi-stage isn't going to work for you, or maybe in addition to multi-stage you need to do this, you can, again, if you're building locally and have a new enough Docker, doesn't work on Docker Hub yet, unfortunately, you can squash your output. And so that way, if you do something in one run statement and then remove it in another run statement, that final squashed layer will be the final unlinked view. So it will remove anything that you may be unlinked in a run command. So that's that can be useful. All right. We're getting towards the end, I promise. Funny, it pops back to PowerPoint really fast, but when I try and go to a web browser or a terminal is when it always hangs up. Okay, the final category here is what we call the mystery. We get image, and we're like, great, what's in it? And then days later, we still don't know what's in it, right? So I've seen things where the Docker file is literally just like, from scratch, copy a file. What the hell is that, right? I don't know what that is. Great, so some file produced by your local build system. It doesn't. I don't know what's in your. Is it Go? Is it C? Is it Java? I don't know what it is. How'd you build that? What is it? Curl pipe bash. Oh, I love curl pipe bash. Total mystery. What'd you curl? What did it do? I don't know. You just curled a random URL off the internet and piped it into bash. Nothing makes my skin crawl more than seeing that from a risk perspective, right? Maybe you're installing software from internal to you sources, right? You're not doing your build on Docker Hub, or you're not using public, public sources, and you're doing a build from your own internal sources, which is not necessarily bad per se, but you don't provide me any documentation about it. Well, what is it? I don't know what you installed, right? I can't see it. I can't look at it myself. I can't validate it, right? Can you provide me some documentation on what you did, please? Or you have a bespoke, convoluted build process. I've seen very large cloud-native projects where after 3 hours of reading through dozens of different files, you've been through make, you've been through Bazel, you've been through bash, you've been through all these things, and you still don't know what the hell is in the image because their build process is just so obfuscated and so obtuse that good luck trying to figure it out. So how do we solve these? Well, do the build inside your image. Use the multi-stage build thing. That way, a lot of times those from scratch copy single file is people who are trying to do the right thing and say, well, I don't need to leave 3 gigs of build artifacts around. I only need my single statically built binary. But they aren't aware of multi-stage build. So do multi-stage build. Document your build process. It's remarkable to me the number of open source projects and things out there I run across where there's zero documentation about how to build a release. It's usually one person who's like, oh, yeah, you need to talk to them. They're the release person. They know how to do it. Does anyone else know? Does anyone know what they do? No. Wonderful. What happens if they get hit by a bus tomorrow? So just a simple README that would take maybe 10 minutes to write and put it somewhere in your GitHub repo will help immensely in that regard. Make it easy to find your source in your Docker file. If you're building stuff that's open source, it's closed source, obviously not. There's a way of doing labels. I think you've seen some labels in my examples. The labels in my example are based on an older scheme, the label-schema.org scheme. That has now been deprecated in favor of the OCI spec, which is the top link there, the open container spec, has an annotation section on again, how you can do this. And the awesome thing is that some of these common labels, which is what the result of this is, are things like, what is the URL to my source? What is the URL to my Docker file? What is the VCS rev identifier of this build? So if you're not say building from a tag out of Git, but you're building from a hash for whatever reason, that's the way you want to do it. Great, give me the hash. So I know what you built. There's some great ways of doing that. That'll be in your resulting image. I can do a Docker image inspect. Oh, you follow the OCI annotation standard. Awesome. Let me go find out where your source is. Let me go find what rev you built from. If you really must use curl, you really have to download something outside of a kind of well-understood package manager installer thing. So here I'm talking about apt, yum, pip, Go and nodes, various stuff. We can debate the security of those things all we want, but they are at least well understood and somewhat hand wavy, vetted mediums for doing distribution. Curl from random URL on the internet is not. So if you really do have to do a curl, though, because it's something that's not hosted someplace that we trust for some reason, at least show me that you care and you're doing some level of validation on it. Have a signature that you're validating. Validate a checksum or a hash or something of what you downloaded. Don't just pipe it directly into bash, please. Okay. So let's say you followed all this and you still have a container. We have a container now. Maybe it's well built, but guess what? We still have to do open source software compliance on it, because now I want to ship something based on your container. Right? You're an open source software developer. You created this wonderful thing. You want everyone to use it. You gave it a really great permissive license. You want everyone to use it. You followed all these directions. Great. If I'm going to ship something based on top of that, I still have to know what's in it. I still have my obligations under my compliance standards, and I still have an open source software obligation as well. So how do I go about doing this? How do I know what components are in this image and what are their licenses? And how do I know if they're up to date? So there's a ton of tools for this. This is another very popular area right now and a very popular space. There's a number of startups in this space, and it's very, very hot. So here's a couple that I've used here. This is by no means an exhaustive list. Like I said, this is an extremely hot and popular space right now, so you can find a ton of solutions. The one I personally like the best right now myself is Anchor, and I'm going to give a demo, the last demo I'm going to give here in just a minute of one of their tools. VMware also has this thing called Turn. There was a talk last year from a VMware engineer about it. It's pretty interesting. It's a little slow, but it can really find some interesting stuff that some of the other tools don't find, and I think that's because it probably uses a more thorough methodology, but that's also why it can be slow. As I said, the Linux Foundation itself has a number of reference tools for doing open source software compliance that you can check out. I think everyone's heard of Claire. It's embedded in Quay. You can also run it standalone as a way of kind of doing image scanning. There's a company called Twistlock out there. There's literally a ton of these different things. Some open source, some commercial, some a mix of both. So Anchor, I'm going to talk briefly about them, give a final demo on them, and then we'll go to Q&A. And again, a disclosure here, Anchor is a partner of mine at work. The products I work on, we have built a tooling for our container-based products that I work on. We've built tooling around Anchor to help us do all the things I have been talking about. So what is Anchor? So it is an open source project, and there's a commercial company behind it as well. And it takes images, it takes Docker images, and it can scan them and audit them for you. So it's able to inventory a wide range of kind of packages. I've got the list here, you can see, and then monitor them for vulnerabilities and CVEs. So it incorporates, say, the standard NVD CVE feed as well as vendor CVEs. So it pulls the feeds from Red Hat, Alpine, Canonical, all sorts of different places to try and give you an accurate picture, both of what's inside your image as well as, is it up to date? What CVEs do you have? It also has a very rich policy engine that can allow you to make policy decisions and do enforcement on a number of things. You can enforce on license, you can enforce on content, you can enforce on CVE severity, but you can also enforce on container best practices, things like, hey, you don't have a user statement here, right? That's one of the newer OCI things is don't run everything as root, right? There's a number of integrations available out of the box, Jenkins, CircleCI, and my personal favorite, GitHub Actions. It has other ones, but I want to talk about and demo the GitHub Actions one. So Anchor.com is the commercial company. GitHub.com, Anchor Engine is the open source Anchor Engine piece. The GitHub Actions, so that's the last thing I want to talk about here. I'm going to demo this here in just a minute. So if you're not familiar with GitHub Actions, if you haven't encountered these yet, they're somewhat new. GitHub rolled them out mid to late last year, sometime late summer, early fall, if I remember correctly. It's really awesome. It's available on GitHub.com. Unfortunately, it's not in GitHub Enterprise yet, much to my lament, since we're required to use GitHub Enterprise internally. And it's a really great feature that GitHub has rolled out that basically allows you to turn GitHub itself into your CI and CD system for you. So you can define what they call these actions with these different runners, and you can, when you create a pull request, there's actually a ton of different events that a GitHub action can trigger on, pull request being the most common. You can have it basically run through all types of different stuff to basically be your own CI system. Anchor has created so you can write your own actions, of course, and then there's a marketplace for actions. So Anchor's created an action. It's free. Another thing I love about it. That what it does is it will take a container that you build via GitHub Action, and it'll scan it with Anchor and give you a report on that. So let me we'll hop out of PowerPoint one more time, and I will show you what this looks like in action. Once the screen catches up to us. Okay, so I'm back in the terminal here, and I'm in my checked out Docker example, right? So what we're going to do is we're going to do a PR. We're going to make a change to one of these images. We're going to do a PR. We're going to post it to GitHub, and we're going to see this action run through. So first, let me show you the action itself and how to configure it. There's documentation for this that I provided in there, but it's pretty simple. You configure all GitHub actions in a directory called .github, and there's a bunch of things you can do there, but pretty much anything in .github/workflows, you write a YAML file, because of course don't we all program YAML these days. and you define what you want to do. So this is a very simple example. All I'm doing is just running a scan. I'm not defining a policy. I'm not having this vote. So this can vote. You can create this as a job that votes. So you configure your GitHub repo to say, hey, all the CI jobs have to pass. So this thing can fail, say no. And if you configured your GitHub repo right, it means you can't merge. So you can kind of make this part of your CI process. But again, all I'm doing here is just run it and just like cat the output so we can see what it is. So it's pretty simple. This is mostly here what you're looking at is GitHub Action syntax. So I'm saying, I'm naming it anchor example. I want it to run on pull requests whenever they're opened or edited. Now I define the job. You can have multiple jobs, of course, but for the build job, I just want it to run on Ubuntu latest. Again, this is part of the GitHub Actions. Needs to do a checkout first. That's what this is. This is a provided default action. Then I'm going to build a Docker image. Again, real simple, just simple Docker build. And then I'm going to configure it to use Anchor's scanning action. So this is a GitHub action that Anchor's created and published. And then I provided a reference image, the Docker file, and you'll do the scan. And then finally what I do is I'm just kind of catting the output so we can look at it. You can, of course, do other things with the output. You can post them places. A lot of different things you can do. I'm just catting it as a simple example. So great. We're gonna make a change to this Docker file now, right? So we're gonna modify dockerfile.curl. Whoa, that's kind of ugly formatting. Oh well. And you know what? I need VI in this container, right? So I did. I'm going to install something new. I'm going to install Vim. Doesn't really matter. Okay, scale demo. Oops. And we're going to push this up to GitHub as its own branch. Great. And it gives me the URL. And I'm going to create a PR from this. Oh, whoops. Opened a new terminal. I didn't really mean to do that. OK. And blah, blah, blah. It's just a demo PR. So we have this thing builds as expected, waiting for status to be reported. So again, anchor example build on pull request. This is the GitHub action that's running, right? And if we go here to the details, now this is actually you can get to it by going to the actions list in your nav bar for your repo as well. But here's what's happening. So it's setting up the job. It already ran the checkout action for me. This is where it actually clones this repo at this PR. It's building the Docker image. I can expand or is it waiting for that to start? Oh, yeah, I guess that one hasn't started yet. But you can see here's all the output of the action itself as it's running. So it's built the Docker image now. See the Docker. The UI for it's a little funny when it's the smallest screen, which I have to use for a projector. So here's the standard Docker build. We get the full Docker build output. And it's running the scan now. The scan will take a minute or two. And so what it's doing here is it's actually, Anchor publishes a kind of a pre-built container that then they update it, I think it's updated daily, if I remember correctly, that contains all of the latest updates of all the various feeds, right? And so it publishes that container, and what's doing is it's using this other container that has all these updated feeds as well as the Anchor code to basically take this image I just built, take it apart, analyze it, process it, figure out what its dependencies, its components are, their licenses, things like that, as well as then scanning it against all this feed data that it has and saying, well, what vulnerabilities exist here. You can, via the policy, you can define a lot of things, right? You can define a threshold for CVs that you see. Maybe you're like, I don't care about anything below a CVSS v3 score of 7. Just don't even show it to me. Maybe you only care about things that have fixes. Maybe you're like, yeah, look, I know you always have some CV somewhere or another that doesn't have a fix. Only show me CVs that have fixes, right? Because that's something I can do something about potentially, right? Like I said, there's a lot of things you can do with the policy engine, and and make it much richer, right? Again, I'm just using a very default standard configuration. Boy, this is taking a little bit longer than I had hoped. While we're here, let's see if Docker Hub has updated, because earlier we did a build of Docker Hub to see if it was gonna, and it did, great. So we can look at this while we're waiting on that. So about 33 minutes ago during the presentation, I did that manual trigger of base latest, right, saying, hey, let's rebuild that. Well, about 31 minutes ago, well, I guess it was fast, it detected that that had changed and was published, and so it rebuilt the curl image. So that's that repository link thing I talked about at the beginning in action. Docker Hub was fast today, it seems. Sometimes in testing over the last week, preparing for this demo, sometimes it took more than an hour. So, okay, and by going there, hey, we're done. So here you can see what Anchor can produce. So it's producing several different content files. So there's no gems, there's no Java, there's no NPMs. There's a bunch of OS data. So we have the add user package. There's the version. That one doesn't happen to have a license for some reason. License is a weird thing. It depends on what's written into the D package, and sometimes they're there, sometimes they're not. Here's the apt package. So you can see it's got all the content here. And then also, if we scroll down later on, I probably could have made this a little cleaner for myself. It cats out the CVE data. Right, so here we go. So here's, it's applying the policy stuff. And like I said, you can see there's a bunch of things you can configure in your policy engine to do, right? And this is what it's basically saying. Oh, okay, well, you want me to do this thing. It's a very default configuration that's baked into their action by default. And then what we can get in the results, here we go, vulnerabilities. So it's going to start telling me, hey, guess what? So the version of apt you have has this CVE from 2011, severity negligible, probably because Debian said they wouldn't fix it. Most of these are probably because Debian said they wouldn't fix it. But you can see all the CVEs here. Again, you can configure it to say, show me only things that have fixes, things like that. I didn't do that because I just wanted to have a simple config that uses the built-in stuff in their action. But you can see all that data published there. Like I said, you can use the policy engine to then make decisions. So you can configure something that says, any CV that has a fix for it means that this action should fail. You can configure it to vote on your repo. If you go to settings here in your repository, under branch protection rules, if you configure it for a branch, you can do things that says require status checks to pass. And you'll notice build, because that's what I named it. But this is that action that is the anchor action, right? So you can make these actions vote. And you can, using that policy language, you can make that action result in a failure. And with this configuration, you can say, well, that means it's not mergeable, right? So you can basically use GitHub to basically become your own CI system, scan your images. There's a lot more you can do with GitHub Actions. They're really cool. Okay, we're done with that. So Q&A. There's a link to my example repo that I was using here, and all the code is in there. The presentation, a version of this presentation and the video of this will be posted to the Scale website at some point. Like I said, I'm happy to take questions. We only have officially 2 minutes left till 12:30, but I believe the next session is not in this room till 1:30, so I'm happy to stick around if people have questions. If you do have questions, though, there's a microphone sitting by the projector. The request is if you could use the microphone so that they can record the question for the video. You will need to turn it on, though. There's a little button there.
So a lot of these compliance tools, they're as good as the database that backs them. Mm-hmm. And there are companies that specialize in creating those databases, mm-hmm. right? How does the Anchor database, you mentioned that it goes to some of the open source CVE repositories. Mm-hmm. In your experience, how good is it compared to Claire or some of the other toolings?
Most of the tools out there, like you said, there's a number of public sources, and there's a couple of paid private sources for vulnerability data. And your question is around how do I find Anchor compares to Claire or another one of the tools? I would say I've been relatively pleased with the results of Anchor. Most of the problems that we have seen with the data has been a flaw in the original source, and when pointed out, they work to get it corrected for us, right? It is very difficult to clean that data because there's a metric ton of it. I mean, the feeds are quite large. I mean, one of the Red Hat feeds alone is a couple of gigs with some of the data they publish, right? Not to say that Red Hat isn't secure, I'm just saying there's a lot of data there. And so oftentimes, all of these companies, whether they're open source or commercial, there's certain things they know to do, but a lot of times it's a matter of, well, who hits it and opens a support case and says, this looks wrong. And, oh, yeah, that is wrong. We'll go, we'll correct it, right? It's very difficult to write general rules. So I have found that most of the tools I've used suffer kind of from the same problem set, which is this data is not the cleanest data in the world to begin with, right?
Sorry, one follow-up question. In the GitHub action that you mentioned, is there a way to whitelist certain things that, for example, Debian will not fix and still let it vote?
Yeah, so there's the policy engine in Anchor is very rich and allows you to do that. So you can flag things like only show me stuff that has fixes. So to your specific question, you could do something that says, oh, show me something that only show me CVEs for which the vendor has shipped a fix, right? Because that's something I could fix. So you could say that if you wanted to. You can also whitelist certain CVEs. You can blacklist certain CVEs. I mean, there's a lot of things you can do. You can turn different rules on and off for the compliance stuff. I don't think I was running any of the compliance stuff in that action because, again, it's just a simple, hey, look, you need to, the basic GitHub action that they have is pretty cool in that it gives you a ton of data that you as a human could take action on. But if you want to start doing automated things like automated voting and stuff like that, you really need to write your own policy that adheres to whatever your standard is, right? And by standard there, I mean either a compliance standard you're trying to meet or your company's policy and standard, right? But you can do that. It is possible to do that with the action. I should say Anchor also, if you do like an on-prem deploy of it, there's a full RESTful API that you can use to do all types of things with, and policy engines, and it's really a pretty cool tool. So, any other questions? Anyone? Oh, I think we got one. Oh, did you turn the?
So for multi-stage builds, how do you do caching?
I'm not a Docker expert on that. Well, each layer in the multi-stage build, I think, will still. I'm not sure. I'll be honest. I'm not 100% sure. I believe that each layer in the multi-stage build will still get looked and matched against the cache and then cached there. So potentially, in your local build cache, if you're doing a multi-stage build, right? If you're doing multiple that use a similar set of steps, you would get that benefit. Now, if you're, you're not going to see those multiple stages necessarily pushed up to something like your internal Docker registry or Docker Hub, because typically what happens at the end of the multi-stage build, you can pass a flag to multi-stage build to keep all of the resulting containers. So in my example where I had the first from and the second one, we're only keeping the last one. You can actually pass a flag to build that says keep that previous one. So you could potentially do things like store that sort of stuff for more caching. But I think what will happen is it will match against your local cache for the multi-stage build, but that's about the extent of it. It won't necessarily have them stored on your registry for pulling and that sort of stuff, right? But I suppose you could save all and push all layers as well if you wanted to. I know there's an option to save it, and since it's saved, it's in your image cache. Just tag it and push it, right? So, though I will say about image caching is an interesting thing with Docker. Docker image caching is pretty cool, but it also has some limits. So sometimes if you have a run command that is simply invoking your package manager to update its contents and then do like a dist upgrade or the equivalent there, sometimes I have seen Docker image cache get that wrong, where it says, hey, this looks like the same command. I'm going to cache this. Yeah, but the results aren't the same. So there can be some issues there. So, buyer beware. Frequently, what we do is we by policy just do all of our builds with no caches. Sure, they're a little bit slower, but whatever. It's just robots, right? I mean, and you know, we host internal mirrors of everything, so it's all, you know, direct queries inside of our own, you know, data center to our own caches. That's the benefit of working for a very large company. You can do it that way, right? But yeah. So, any other questions? No? Okay. Well, thank you, everyone. Hope there was something useful and valuable.